two for the group. All right, so we are going to hit 13 and 19 from yesterday. I do look at those Google forms. I try to look at everything. So 13 and 19 were the ones people had questions on, and you're tested on both of those types. So that sometimes if you have a question, I'm like, yeah, they don't really need to know that. It's good to know. But nice of you to show up, Charlie. Anyway, so we are going to do 13, 19, then take some notes. It's kind of one of the harder sections this chapter today because it's all trig. And so that tends to make people slow down a little bit. And then there'll be a worksheet today. I'm going to just, because this is the last time I'll see you guys till next week. For tomorrow, it looks like you're going to take a formative quiz, so that won't go in my grade book, but I picked, I think it's 6 test questions, and I changed numbers just to see where you're at on those. So if it goes well, great. If it doesn't, there's a Google Meet on Friday where I'll go through each one of them. So I'd say if you get more than one wrong, I'd show up to the Google Meet. It'll take about 15 minutes. It won't be like a full hour on Friday. It'd just be, and then I have that linked on Friday. So on Friday, you're going to do some warm-ups and some Delta math. So just so you have the work laid out for you. So today, let's go into yesterday's assignment. It was 13 and 19 that stood out to me on the Google Forms. And I have one of each type on your test. So if you want to look at what you did, or if you just want to watch me, whatever floats your boat, that's good. Just a second, I've got the spinning wheel of doom going over there. I'm sure it'll stop. Here we go. All right, so remember, no matter what, when you are approaching a constant, by that I mean not one of the infinities, you plug this. Okay, there. My smartboard's being dumb today. All right, you plug this in for that. You hope you don't get 0 over 0, but on this one I would. I'd get f of h minus, excuse me, I'd get f of 0 minus f of 0 over 0. It's an issue, right? F of x, sorry, minus f of x over 0. I've got 0 over 0. I would love to figure out how I can get that thing causing the 0 to cancel. In this case, it's an h, right? If it was h minus 3, I'd say, well, it's h equals 3. But h equals 0 is what's going to be my issue. I want to cancel that off. So first thing I need to do is figure out what this is for this function. So I'm going to take x plus h, so just watch, or if you want to write it down, and I'm going to do function composition from algebra 2. I'm just going to put an x plus h in here for all of the x's. So I'll do 3 times x plus h quantity squared minus 2 times x plus h. You good so far? What do you like? Harrison, you good? Yep. All right, so then what I'll do with this f of x plus h is I really want to suck the h out of it because I know that I'm going to be canceling the h. You always end up canceling the issue in the denominator. So I'm going to FOIL that, and I'm not going to go over foiling, but you'd have first outside and insides would both be xh, and then lasts. So I'm just getting this chunk right here. How are we to, make sense? Right, Frank? And then I'll distribute this in, because I'm on the h attack here. And then I'll put the 3 in. So again, this is just a bunch of scratch work here for the problem. This whole expression right here is just f of x plus h. Right, Charlie? So then what do I need to do with it? I need to subtract off f of x. Well, I need to subtract off this. So it'd be a minus 3x squared and a plus 2x. Because remember, I'm subtracting both. Are we good so far? It's all over h. Now watch. This is a really important one because, to be honest, this is in the definition of the derivative when we get to our next chapter. And you're going to find that if you do them right, everything that doesn't have an h in it should cancel. Do you see how everything left has an h in it? Guess what I'll do with the h? What am I going to do with the h on the top? factor it out so I can cancel it. Yeah, so I would do a rewrite, and it's getting long here, but I'd factor that h out, and I'd have 6x plus 3h minus 2, right? So I'm just factoring an h out, an h out, an h out. It's all over h. I will cancel. I'm going to take a limit, and I'm going to plug a 0 in for h. When I do that, that term will go. So I end up with 6x minus 2 as my answer. Do you see how the h left? That 6x minus 2 is actually the derivative of it. You just don't know about derivatives yet. So that was number 13. The other one that stood out, and I am testing you on one like it, so these are good that you guys are being honest on those Google forms. Number 19. All right, so when I plug in a 2 from any direction, I ended up with a 0 over 0. I know something's going to have to cancel. I know it's the 2 minus x, right? I just have to get the top factored. So in the notes, I think I said always make sure when you have these quadratics that you get a positive lead term. You don't have to, but I think it's easier to factor when that's positive. So I'm going to take a negative out just so that I have an easier time factoring it. How's that look? Good, Langban? All right, so then I'd factor this. I know it has to have an x minus 2 in it because it's going to be canceling. You might say, but that's a 2 minus x. How do these cancel? What do they cancel to make? They don't make it, they're not exactly the same, but even if you threw in a fake number like a 9, whoops, you'll see that they end up being opposites, right? What do these cancel to make? Negative 1. Yeah, so there will be, and I know there's going to be an x minus 2 here, so I'm going to have a 3x. I'm going to have an x minus 2, I'm sure, right? And then this would be a plus 1. Am I good? And then this is all over the absolute value of 2 minus x. This approach is really important. It's going to affect the sign of your answer being right or wrong. So I'm approaching 2 from the right. So here's the deal. I know these cancel, but I'm not sure if they make a 1 or a negative 1. They have to be one or the other. They're the same expression, don't you agree? They are. But to decide, I would just go to the right of 1. Pick any number that you would like. I mean 2. You could pick 2.1 or 7. But I would just go test it, to be honest. And I gave you a longer way in the notes because that's how it's taught in a textbook. But for me, I don't do that longer way. I do what I did at the end of the notes where I just said, let me just choose a 7 and see how these cancel. I think it's easier. So this would be a positive 5, correct? On the bottom would be the absolute value of negative 5, which is also positive 5. So these are going to cancel to make a 1. They either make a 1 or a negative 1. So if you had to guess, Charlie, at least guess one of those two numbers, right? But don't guess. So those are canceling to make a 1. So my answer is going to be the limit as x approaches 2 from the right of negative, because that's there, 3x plus 1. So when I plug it in, it looks like I'm getting a negative 7. Are we good on those two now? I think I'd say half the people chose this one on the Google form as one they struggled with. So we'll be done with that. On your notes, go to, I think it's like page 49. It's got some trig stuff in it. I just have to page back because that worksheet's at the end of my file. So it's right before this continuity. Yeah, it's the Triggy stuff. You're going to need a calculator. At least some of you, if you can have a calculator out, if you, maybe half of you can help me make a table. My smartboard doesn't really like me toggling between the calculator and the smart notebook while I'm recording. So I kind of, it should be recording. Yep, it is. All right, so if a couple people could have a calculator on. So we've already looked at how to evaluate limits by direct substitution. Remember, if we don't get 0 over 0 or 0 in the denominator, really, we don't really have any issues. So this first one, all you need to do is plug 2 pi thirds in and see where you are. So if I plug the 2 pi thirds in, the 3's would cancel, and I'd have sine of 2 pi over 2 pi. That's not a problem, right? Because there isn't a 0 in the denominator. So you just need to be 100% sure. What page is this on, by the way? 49? All right. You need to be 100% sure what the sine of 2 pi is. Well, it's at the point 1 comma 0. sine is the y value. So a 0 on the top is not an issue unless there's also a 0 on the bottom. What do you think my answer is? What's my answer? 0. Yeah, now notice, don't lose track of what that means graphically. That means if I were to graph this at 2 pi over 3, let's say it's over here, as I approach 2 pi over 3 from both directions, my graph is approaching 0. And not only that, it's solid there because 0 wasn't an issue. Okay, so I'm not going to do that one because I think you get the direct substitution. The problem is, what do you do? We talked about what you do if it was like a polynomial over a polynomial. You factor, cancel, replug, right? I can't walk too far away from my screen because I'm recording. If it had the root in it, how did we deal with it? Do you remember what word? Rationalize it by using the conjugate of the level the root's on. If the root's on the top, it's conjugate of the top. If the root's on the bottom, it's conjugate of the bottom, right? And then we also did, well, what if there's a complex fraction? Well, we get rid of it. Crisscross, applesauce, and we clean it up. Well, what if it's Triggy? That's where it gets, it's not as concrete of an answer for me. Like if Charlie were to say, LaRoot, how do I deal with the trig ones? I'd say it depends. I can't say factor, cancel, replug. Because it just depends. You have to fart around with it, which gets frustrating. So you're going to get a little more frustrated on the worksheet today because the first thing you try might not work and you might have to try something else. Where yesterday, weren't you kind of cruising through for the most part? All right, so let's go see what happens here when I try direct substitution. I get 1 minus cosine 0. Notice the unit circle's back. Last year's students told you in their advice, know your unit circle. And it's been 2 of the 3 days this week. It's been with us. So cosine 0, 100% sure, because otherwise you're not going to know if this limit needs more work or not. All right, so I end up getting cosine 0 is 1, so 1 minus 1 is 0, and the sign there is 0 because it's the y and I squared, I get 0. So now I'm stuck and nothing I've learned so far works. So what you have to know is with the trig, you're going to try rewriting things so it works. So I want you to go over here, and if you have a tangent in the problem and things aren't working, Harrison, what could you replace it with? Sine over cosine. And maybe then the cosines will cancel, and maybe that was causing the problem, right? If it was a cotangent, you could replace it with cosine over sine, right? If there's a secant theta, what might you want to try? It might not work, but what might you want to try? Do you know that? What secant? Somebody help me. 1 over what? Cosine, yep. The S's and the C's go together. Think St. Cloud in here. It's going to hold on through the year, actually, because it's going to come into play later. So cosecant is 1 over sine. And then you don't have to know your big trig identities in here, like the double angle formula and the power reducing and all those things that kind of made you puke in your mouth in pre-calc where you're like, but you do really need to have this one down for the year. What is cosine squared plus sine squared? That one you need to know. 1. Okay? Cosine squared plus sine squared is 1. Keep in mind y. Cosine's x squared plus y squared equals 1. That makes sense if you're on the unit circle, right? All right, anyway, so let's go over here and say, well, how could I rewrite that one? So you actually have 2 options with this, and that's why normally we work together on almost everything. But with this COVID stuff, it's kind of hard. A couple of you did yesterday, but or last time, but it's hard. Like I had a couple boys yesterday who went to Bloom's to work together, and they just sat across from each other. Totally fine. But normally I make you. So, but if you're not comfortable, I can't. Anyway, so you might be working with somebody who says, oh, I'm going to do it differently, and it might be okay. But on this one, what do you think I could rewrite of all of these? Because I got 0 over 0, so something's up. I need to rewrite one of them. What do you think, Kalia?
Sine squared.
I can, right? I can rewrite sine squared as something else. Do you know what I can rewrite it as?
1 minus cosine.
There it is. Now, that makes me feel good. Here's why. Because once I write it as, if you're listening from home, she said 1 minus cosine squared theta. That makes me feel good, Harrison, because now I see factoring and canceling when I'm looking ahead to it, right? Who's the absent one? Ava? Dylan. And Ava, I think. Oh, there she is. You're covering your cute face and your hair was up in your flip there. I'm like, who is that? It's because you haven't worn your hair up yet. See, I watched those, and you actually won. You're the one you and another girl's the one I'm sending to the people who said they didn't know how to do it. Okay. So you are the people who said, I wasn't quite sure, I sent them your video, but it doesn't register with your Facebook. You're so cute. You're all cute. All right, so anyway, I'm going to factor the bottom. Let's go do that. It's a difference of squares, 1 minus cosine theta. 8 of us should feel very good about this on her worksheet today. She's like, I think I'm on the right track. Here's why, right? I am going to cancel these suckers and put a 1 over here and replug, just like we always have, all right? So when I plug this in, bam, what's my limit? What's cosine 0? Don't guess. It's either 0 or 1. But only one of those will result in the correct answer. So no guessing going on. 100% sure what's cosine 0? It's silence. What's cosine 0? 1. Okay, so this would be equal to 1/2. So if I were to graph this one, what I would see is as I come in at 0 from both sides, I'm up at a 1/2, but at a 1/2, there's a what? Hole, because of the open dot. Yeah, you guys are really getting this, I think. I'm hoping. Limits are actually, I'm going to be honest, if you were to ask AB or BC, what's the hardest between limits, derivatives, and integrals? It would be 50-50 between limits and integrals. So this isn't the easiest stuff we do all year. They really like derivatives. But so let's go practice this a little bit. I might not do all of them. When I plug in a 3 pi halves, okay, now notice, if I plug in a 3 pi over 2, the issue is going to be that, let's go rewrite it, limit theta approaches 3 pi over 2 of 3 times sine theta over cosine theta times cosine theta. This one actually does have an issue. It didn't look like there was a denominator, right? So you might say, oh, there's no problem here, right? But there is a problem here because cosine at 3 pi halves is the x value. It's down here and it's 0. This does have a 0 over 0 in it, but the minute I rewrite it, I see the canceling. So that one was easy, don't you think? So when I replug in the 3 pi over 2, what's the sign over here? 100% sure. What's the sign at 3 pi halves? Go ahead, Jake, right?
Yeah, -1.
Thank you. So this is just a -1, so the answer is -3. That is your limit. On the next one, all right, I have that secant there, and you might say, but I'm not getting a 0 over 0. You actually are, because secant itself is a fraction, and what fraction is it? 1 over cosine, right? So the minute you notice that, Charlie, you'll cancel replug. I'm not going to do that. Do you get how these easier ones work? Same up here. What do you think you're going to replace tangent with? Yes, sine over cosine. So let's go try maybe, let's move on, because I think that, are we good? If I feel a vibe, I like to move on. The notes are always the most I'll ever do, all right? So you guys, those of you at home, they're nodding, they're focused, they get it. So I need somebody, I said have a calculator out. Did some of you do that? We don't all need to. But I want you, first of all, to make sure you're in radian mode. So hit your mode button. It defaults to that, so you should be in radian mode, but just in case, we only work with radians in here. And what I want you to do is go to the f of x, those of you with your calculators for me, do sine of x over x. I know you guys would all know how to do it, so that's why I'm just going to share the labor here, and I'll just pick on a few people. Make sure your table's set to ask from last week, but unless you've messed with it, it should be fine. Didn't we set the table set to independent acts. So Harrison, can you type in a negative 0.01 and give me to 3 decimal places? And then I'll have Langban, if you could do this one. And then Jake, if you could do that one. I'm looking at people who have their calculators out. Mallory, if you could give me this guy. What's your name again? Peyton. Give me this guy. Blake doesn't have a calculator, and you have a calculator, right? Westgard, you give me that one. All right, so let's go back, and whoever I told to do this one, I think it was Harrison. What is it? 0.999. Oh, this one. Who did I ask? I don't remember. Langban, I think it was you. What'd you say? Oh, I'll skip along then. Who did I ask to do this one?
Me.
What is it?
I'm not there yet.
God, what's taking so long?
My
What?
calculator.
Oh, Westgard, do you have yours?
I got 0.99.
0.999. Who else did I give one to?
I got 1.
And who are you?
0.001.
0.00. Yours rounded to 1?
Yeah.
Okay, how about right here? What's happening is there's so many 9s, your calculator's probably rounding it, but my guess is you have it set at a float. That's what my guess is. That was just more 9s, which does round to 1. How about this one? Any of them? Jake, do you have yours?
No.
People at home, they're really slow. Harrison, do you have all of them? Oh, thank you. 9999999999999, and there's just more and more of them. Now take a look. Zero's right in here, correct? And we're creeping up on 0. So watch what happens. Sine of 0 over 0, it gave me this. There's nothing I can do to rewrite it. Does that make sense? Sine is naked. Once you get into sines and cosines, that's at its bare bones. You can't mess with those. I still got 0 over 0, but as I'm coming in from the left, my heart tells me I'm at 1. When I'm coming in from the right, my heart tells me I'm at 1. And I believe I'm at 1 here. Now, those of you with your calculators out, hit Zoom 7. That's the trig set. If you didn't know that, if you've never used Zoom 6, makes a 10 by 10 grid. Zoom 7 sets it to go by pi halves. Did you guys know that? Have you always been manually doing your trig ones? Don't do that anymore. Anytime you're graphing trig, what button are you going to hit? Zoom 7. It makes a nice, it goes 0, pi halves, pi, 3, like you're going around the unit circle. It sets the grid that way. So if you didn't know that, what they're looking at, I'm going to go grab somebody's calculator just because some of you don't have one. Did you grab it? What they're looking at is that function went like this and like that. It was kind of a little bit more stretched out on the top, but good enough. We came in at both sides, right? Her calculator did not show the hole there. Your calculator will not show the holes, right? You can't see it. And take a look. Guess how high up this is based on my table? 1. Okay? So that is not a proof, by the way. That's an observation. We will prove this later. We just don't know how yet. So you're just going to have to trust that it is 1 for sure. And I'm going to tell you this one, if we were to do it, has the same results. We end up creeping up on 1 from both directions. Harrison could try it on his calculator. He's going to get a bunch of 9s, 0.99999 from both sides. So 1, 1, 1. What do you think it would be if it had been sine of 5 theta over 5 theta? Guess what it creeps up on? 1. How about sine of 10 theta over 10 theta? 1. So, what do you think this can always be for you when you're cleaning your stuff up today? Sine of some stuff over the same stuff, that actually is 1 for sure. So your goal is to get the same stuff in the argument of sine as is on the bottom, because you're going to be able to say that goes to 1. So that's one of the new trig things you just learned. You're going to memorize it for now, which I hate. Later in the year, you're going to forget it, but that's going to be okay because we're going to have a better way to get that one. Harrison, the worst way to get a limit is off the table because that's not proof. How do I know it ever, you know what I mean? But we just don't have the math yet to prove it, so we're going by observation. Calculator people, faster this time, okay? Go enter this, make sure the top is in parentheses. So 1 minus cosine x, and I think Jake and Harrison, you're faster in your calculators. If you guys could go enter that really quickly. Or were you the slow one?
I got it this time, I think.
Yay! All right, so we're going to have them on their calculators creep in again on 0 from the left, and we're just going to start because we just changed it, right? By the way, a direct substitution of 0 in here gives you 1 minus 1, 0 over 0. And I can't mess with cosine because it's as bare as it gets, right? So, we're going to fill this in. Harrison, do you have a couple for me? Let's go to the left. 100.
995.
Really?
I'll read to it.
Like, I know what it's supposed to be, so I'm like, pumpkin. Did you put the top in parentheses? Are you in radian mode? Jake?
Is it negative 0.005?
Uh-huh. What's this one?
Negative 0.0005.
Uh-huh. You might say, LaRude, why don't you just tell us? Because I want you to see. I don't just pull these numbers out of my butt, right? Jake, this guy.
Negative 0.00005.
Okay. What do you think it's creeping up on based on the table as we come in from the left? What number? It's getting really 0. Yeah, it's getting very close to 0. As I come in from the right, guess what happens? The exact same thing, except this is positive 0.0005. Harrison, did you fix your issue?
Try.
It's a slow day for group A today. Is this group A? My favorite group of the day. They're my only group of the day. Just kidding. All right, so where am I? I'm gonna go down here. It says, so what do we think? We've got 2 that we know. Well, I want you to write them down. You'll forget them, to be honest, after chapter 1, but that's okay. As we approach 0, this guy, based on the table and the graph that I just stole from her graph, seemed to be at 1. This guy, which Harrison was on the struggle bus for me for, which is just fine, Jake had your back, seemed on the table to be approaching 0, and if I were to look at your graph of it again, Harper, it would have been at 0, 0. There was a hole. I don't even know what the graph looks like, but there would have had an issue there. So these 2 guys, for today and for about the next 2 weeks, are going to kind of simmer in the back of your brain, and when you see them, you're going to go, oh, that's 1. All right, so let's watch what I mean by that. We'll go practice. Now, I always like to mix old with the new because I don't like you to live in a like monkey see, monkey do mode where she just did this, so I'm going to do the same thing. We don't do that in here. So you'll notice on the first one, I do not get 0 over 0. You might not, right? So I get e to the 0, which is 1, cosine 0, which is 1, over 4. I am done. That did not need to be messed with. So be careful with that. Did I tell you guys? I forget who I told what. But on the AP exam last year, did I tell you guys when I was a reader? And the last question, they assumed was a nasty limit. It was a limit on all forms of the exam. But all across the world, the ones that came through for me to grade had about half of them do this really messy process where if they just plugged it in, they got like this, a 4. They actually got 10 over 1. You know what I mean? But I'd say half the people across the world just assumed it was going to be messy. So I keep throwing that at you because the first thing you should do is plug it in, okay? The next one, though, when I plug it in, I get sine 0 over 0. I do get 0 over 0. And I just told you, Charlie, that you can't mess with sine. I can mess with tangent. Secant, cosecant, cotangent. But sine's as bare naked as it gets. This almost looks like this is what your goal is to get, by the way. Sine of some stuff over the same stuff. Because we just verified on our calculators that that always goes to 1. It's so close, Jake. Wouldn't you agree?
Yeah.
All it needs, and this is what I love about math. Guess what? If you want there, Frank, to be a 4 on the bottom, you can go put one there. Watch. That is legal. I can multiply anything by a 4. I just can't divide by 0. Math is nice that way, right? So Kalia, the only problem is if you decide to do something math, like when you first learned algebra and little Mallory was in x plus 2 equals 11, little Mallory, right? Do I have the right name? And she's like, okay, I'm going to subtract 2. What did she have to do? Undo it by adding 2. You know what I mean? If it was plus 2, she'd subtract 2. And you'd have to do it to both sides to balance it out. Well, you better balance this out then, because you don't want to change it. And the only thing you can multiply by to not change something is the number 1. Correct? So if I'm going to choose, Frank, to put a 4 on the bottom, I better balance it out and put a 4 up here. Right? Wouldn't you agree? What have I just multiplied by? 1. Now watch. I have now created, I'm going to do this first one slowly. I have now created a sine 4 theta that was in the given problem, a theta on the bottom that was in the given problem. I introduced a 4 on the bottom, right here, because if I have the same stuff over the same stuff, we said it's 1. And we learned last, I think it was a couple days ago, that constants can come out front. Did that one nice and slow. So, Harper, what am I going to say this goes to? Because we saw 1. We saw it on our calculators. That's a 1. The answer is 4. Now, guess what? If this had been a 5 theta over theta, guess what it is? I'd do the exact same thing, but guess what the answer would be? 5. Right, now here on your test, I make you show this work for this, and this is what I always get some kids doing. They get the 1 with really bad math, like you can't do that. They go like this. They pull the 4 out, and then they say that goes to 1. You cannot pull part of an angle out front. Does that make sense? And they'll be like, but I got the right answer. I'm like, that's bad math. That doesn't work. It just so happens, sorry, Charlie, you have long legs, big feet. You should get here earlier and sit in the back. All right, so let's go over here. They're cute feet. There's big feet. What size shoes are those?
13.
Holy smoly. He said 13. Big feet. All right, so let's go take a look at this guy. We're going to create what we want. Are you ready? We want to have the sine of 2x over what? 2x, okay? So math is lovely because you get to just fart around with it. So what I'd suggest you do, because I only want a 2 at the bottom, there's really a 1/3 here. I pull that constant out front. Constants always come out front. So I'm going to yank that out front. Does that make sense, Ava? So I'd have the sine of 2x. Oops, better put the 2 on it. Sine of 2x. 2x is an angle. Remember, I wish it was parenthesized on here, to be honest, but it's not wrong if it's not. All right, and I wrote the worksheet, so I guess get out of myself. All right, so here you go. Now, I haven't done anything. I just pulled the constant out front because I can. I would love there to be a 2 in the bottom. Well, I'll put 1 there. But if I divide by 2, what must I also do? Multiply by 2, right? That's really in red, that's a 1. See how I said we're farting around with it? So now you can anticipate what I'm going to do. What am I going to do with this 2? What do you think I'll do with it? Bring it to the front. Thank you, whoever said that. It's hard when you have those masks on. I'm wearing this now because the kids yesterday, when I did wear this instead of the mask, they're like, oh, I can see your face and I don't have to try so hard to figure out what you're saying. I didn't realize that you guys not seeing my mouth made it hard. Like, you have to listen more, don't you? All right, so you're right. That 2 is going to come out front, which is going to give me a 2/3. And then look at what's left. The limit as x approaches 0 of sine of some stuff over the exact same stuff, which we just showed on our calculator, always goes to 1. I want you to try this one in a similar fashion. All right? And those of you at home, pause the video and go try this one. Get what you don't want out front. Create what you want. But just make sure you've never multiplied by anything except 1, disguised as something else. Then I think we'll just do, I just want to do 1, 2 more maybe. Because they seem to be getting it. Can you raise your hand when you're done? Oh, hands are up, more than half. So you should have pulled the 2/3 out front, correct? Because you don't want that, and it's a constant. Constants come out front. You should have put a 5 on the bottom, right? But then you better balance it out with a 5 on the top. Agreed? And then the 5 on the top comes out front as well. Notice I'm not writing because I want you listening. I ended up with a 10/3 in front in my head, right? And then the rest of it was sine 5 theta over 5 theta, which goes to 1. So did we get a 10/3? I've seen lots of nodding. Okay, we're going to move along then. We're going to try making it, we're going to try some more. All right, so here's the deal. On this one, when I put in 0, we get 0 over 0. I want to save some time here. I do see that I can factor on the top, and factoring's always your friend. If you can factor, factor. Okay, factor, we love factoring. All right, it's our favorite F word. All right, better be in there, right? That or FOIL. So when you look at that, what do you think? I've done so many of them, and this is your first day, but think in my head, I always get what I don't want if it's a constant out front. Let's get that 2 out of there. And then let's just keep on going. There's 2 options you can go here with that 1 minus cosine squared. Okay? You could either factor it into 1 minus cosine times 1 minus cosine, or plus cosine, right? Let's do that. Let's go 2 routes. Let's suppose that Jake decides to do that, all right? Because I told you some of them can be done 2 ways. It just depends on where your brain goes. Let's suppose Jake's brain went to this. Are you good, Jake?
Yeah.
All right. And then let's suppose Harrison goes, well, hey, I see one of those ones I was supposed to memorize hiding in there. I'm bracketing it off. What did we say that goes to? Do you remember? 0. I see that part of a product is 0. This is going to 0. This is going, if I were to break, technically you're supposed to do this, guys. So I'll do the first one. Technically you're supposed to say, well, I have a product. So I'm going to break it up into, it was one of those properties that the limit of a product is a product of the limit. So you technically can break any product, sum, or difference up. And I should, just so on this first one, I was doing it in my head and I forget. Sometimes we're reviewing limits in BC as well, and I skipped these steps because they had it last year. But now take a look at what I've got. This part's going to 0. Do you agree, Langben? So I have 2 times 0 times, what's that going to? 100% sure what's cosine 0. It actually doesn't matter because a 0 in a product gives you a 0 no matter what, but because of our unit circle, till we're good at it, what's cosine 0? For sure? 1. So that's going to 1 plus 1, which is 2. What's the answer to this one? What's the answer? 0. Exactly. So notice, now watch, instead of doing another new one, I'm going to do this one a different way, just so you can see it. So let's suppose that Harper, because she said it on the last one, I think it was her, said, yeah, I think I'll do 1 minus cosine squared is sine squared. Is that legal? Yeah, and Frank's pricing, I would have done that. Jake's taking the long way. What's he doing? Don't work with him, right? But this is right, though, right? So let's watch Frank's sine squared theta over theta. Frank, I see hiding in there a sine theta over theta. We like that because it goes to 1. So Frank's going to show me that he sees that because otherwise I assume he guesses. So unfortunately, you have to show work. All right, so Frank, I'm just going to kind of get that sucked out of there. Are you okay with what I just did? Because I wrote it kind of fast. Are you okay with what I just did? Yep. How about you, Blake? You good? So then, this is what Frank says. Hey, that's the one that goes to 1, and sine of 0 is 0. He got 0 too. Who's right? Both of them. Calculus is a pain to grade. Tests, like when I'm grading for every point, because I got to keep in mind there's always people who think a little differently, and there's nothing wrong with red or the black on here. So, on this one, I want you to take a look at number 7. There's a star there. Because a lot of people would get stuck, and I said, you got to play with it, and you've got to see things, okay? Who do you see sort of hiding in here? Let's just start. By the way, when you plug in 0, you get 0 over 0, and we can't play with sines and cosines. We can play with tangents and cosine squareds and secants, but there's really no rewriting of anything. But do you see something hiding in there? Do you see one of them? I actually see both of them. What one do you see hiding in there?
1 minus cosine theta.
Yeah, and did you know that for a fraction, watch, 2 plus 7 plus 1 over 21. Don't you believe that that's 2 21st plus 7 21st plus 1 21st? Can't you break it up? Right? In this class, this is the first time I'm going to say it, and then we'll be saying it all year. If it makes a heart in shape with a single bottom term, if it makes a heart, you can break it apart. That's going to be a go-to. It might not work, but it's legal. So I could break this up into 2. So what I'm saying is she saw that right there. So because you can break it apart. I could say it's 2 plus 7 over 21 plus 1 over 21. Don't you agree? So we're fine. She saw it, but she has to legally show me what she's going to do with it. So a limit of a sum is the sum of the limits. I think this might be the last one I do. Now, let's go take a look at this sucker. And it's addition. Are you ready? What does this one go to based on our observations today? What does the left-hand one go to? We saw it and we liked it because we can replace it with 0. Be careful with that one. Maybe you just know. Should be great. Can you not show the work for that one right now? Do you know what it goes to? Think of it. You're going to put a 2 on the bottom, right? But then you have to put a 2 on the top. And for if you're nodding, you have to throw it out front, right? So what do you think this one's going to become for you? Watch. I want it to be the sine of some stuff over the same stuff. So I'm going to throw a 2 on the bottom. But then I need to throw a 2 on the top, and that can come out front, correct? And what does this go to? Go ahead. You can tell me. 1. What's the limit? Don't lose track. You said 2? That's totally right. Don't lose track of what that means graphically. It means if I were to have Harrison go graph this in his y equals button and hit graph, he's going to see some roly-poly function of some sort. So how do I know it's roly-poly? Because it's a mixture of cosines and sines. I don't know exactly what it's going to look like, but I do know that as he approaches 0 from both directions, the function will pass through 2. However, there'll be a what there? I would actually, Harrison, could you graph that for me so I can actually, for my next class, have a vision? So I'm actually, this is not what it looks like. If it is, it's a fluke. Okay? But don't forget to parenthesize the top. Maybe I'll have you try one on your own. What one looks good? Let's try 9. Fart around with it. If you can do 9, you're good. I'm done talking. And while you're doing that, come around. Do you have the graph for me? And once you enter it, hit zoom 7. I just want to know what it looks like for later in the day so I can actually say, instead of saying it looks something like this. I'm short on this. Oh, that's right. I gave them yesterday's. Oh no, I didn't. Where'd you pick one up? Oh, good. That was one short. I haven't even done this one yet, so I'm kind of looking at it like, how are we going to approach that? And I said, if you can factor, you factor. It makes a heart, you can break it apart. One of those might work, the other might not. They both might work. I'm going to tell you my motto is always factor first because it's my favorite F word. Oh, all right. I wasn't even close. Well,
You were pretty close.
Yeah.
Just higher.
yeah. So actually what that actually looks like on the graph of it is it's kind of funky over here. It goes like this and like this. It takes a dip and then it shoots way up to 2. And you can't see the hole, but and then it does this and that. But the moral of the story is it went through 0, 2. So if the first thing you tried today doesn't work, don't go look at the key. Try to think of something else, and if you can't, then go look at the key. Anyone get it to work? Or you think you got it to work? What do you think? It is 0, I can see it. Now let's see how you got 0. 0 is a great guess. You know what I mean? Honestly, if you don't know, guess 0. But it is, you won't get, a lot of the build-up points. I like to factor first. I saw some of you saw it made a heart and you broke it apart. That might have gotten you the right answer, I don't know. I like to factor first, so is that what you did, hon? So she's saying she factored first, Kalia. Am I saying your name right? Oh, and I like that method because I see both of my friends there. I see a sine x over x times a 1 minus. Did anyone else break it up like that? You did, Jake? Ava, did you? Because here's what I'm seeing now. I'm seeing this. Sine x over x times 1 minus cosine x over x. That is nice. Technically, you're supposed to break them up into 2 products, but this guy goes to what? I have to underline them so people at home know which one I'm talking about. What does the sine x over x one go to? Close. This one goes to 1 on its, if I were to separate the product, and this one goes to 0, and that's 0. Now, I'm not looking at your work, Kalia. You were right with your answer. Is that the work you did? Did anyone have a heart and break it apart? I don't know that you could draw any conclusions from that. It's not that it's wrong. All right, so we're done for your homework. I passed it out already. Did I not give you one, Charlie? Did I give you a packet? No. And you know what? I think I'm out of them. You might have to. No, I'm not out of them. Wait. I'm not out of them. I found one. Who else didn't get one? Oops, sorry. Remember, plug in first. If it doesn't work, play with it. These are way harder. Try not, when you look at the key, you're going to go, oh, okay. But you really want to try to get that aha before you look at the key. So who do you think you're going to mess with on that first one? You gotta get started. Can you mess with 1 minus sine? Or sine squared? Cosine squared, sorry. Which one can you mess with? What do you think? Which one of these can be written? Top or bottom? There. So I'm looking at Charlie's. He's messing with the top. Perfect. You need it 1 minus sine squared. You should feel good about that, right? Because it factors. it cancels. These are hard, by the way. This might be the hardest section of the chapter. So if you're good with it. Oops, I forgot to stop. Have a good one, guys.